All right, today I'm going to teach you how to draw a model of a single displacement reaction that involves limiting reactants. So in this scenario, we have 3 moles of solid aluminum reacting with 3 moles of copper 2 chloride. And from that, we're going to make solid copper metal and aluminum chloride solution. Okay, for these problems, it's super important that we look at our states of matter for everything for our models as well, because it does dictate where that species will be located in the box. So if it's a solid, that means it sinks to the bottom. It does not have a charge. And if it's aqueous, that means it's breaking up into ions in solution. And so we should see those dissociate or separate those ions from each other and would be floating around in our solution. So those are things we're definitely going to keep in mind as we draw our model today. So for our reactant box, I do want to just draw out first all of the reactants that are given. So I need to do 3 moles of aluminum. So those would be here on the bottom. 1, 2, 3. And then 3 moles of copper 2 chloride. I guess I'll write in these first. So this would be Al, Al, Al. Okay, no ions, and we are going to put a little box around it to signify that it's a solid. The next thing that I'm going to draw are the moles of the moles of copper 2 chloride. Now this copper 2 chloride is aqueous, and when something is aqueous, that means it's going to break up into the ions that make it up. So copper 2 chloride is made of Cu2 plus and 2 of those Cl minus ions. So for every mole of copper chloride, it will break up into a set of these ions. Okay, so that's what I'm going to draw. And I'm going to draw 3 sets of those ions. So a total of 3 coppers and 6 chlorides. So let's do that. 3 coppers, 1, 2, 3. And then we're going to have 6 chlorides, 1, 2, 3, 4, 5, 6. Oh dear. 1, 2, 3, 4, 5, 6. Sorry, I was thinking about the aluminum chloride on the other side. Okay, and then for these, then I would add in the charges because these are ions and they do have a charge. So my copper is Cu2 plus, and then each of these green ones is Cl minus. Okay, so 3 moles of aluminum and 3 moles of copper 2 chloride is what we have so far. So now I'm going to take this equation that I have and I am going to use it to determine how much product I will make. Okay, so in my reaction, it says I need 2 moles of aluminum and 3 moles of copper 2 chloride in order to make this set of products, so 3 coppers and 2 aluminum chlorides. So what I'm going to do is partition off or separate off, section off with a dotted line the reactants that are necessary in my recipe. So 2 aluminums, and then I need 3 copper chlorides, and that's actually all of this copper chloride. So I'm going to need all of those in order to make this set of products, 3 copper solids and 2 aluminum chlorides. Okay, so from that dotted partitioned area, I can make those products. So I'm going to go ahead and draw those in. My copper, I will make 3 solid coppers. That solid copper does not have a charge. And I am going to put a box around it to show that it's a solid. And then 2 aluminum chlorides. Now my aluminum chloride is a solution, so it will be floating at the top, and I will have 2 aluminums and 6 chlorides around them, right? So aluminum is Al3+, chloride is Cl-. So I need 3 of those Cl minuses to balance the charge of 1 Al3 plus. Okay, so from, again, my 2 aluminums and my 3 copper chlorides, I'm able to make those products that we see in the box. Okay, now the last thing I have to remember is, well, what about this aluminum? It was not used up in the reaction. So I used up all my copper chloride, but I did not use all of my aluminum. We call that our excess reactant, okay? And we also want to draw that on the product side. No, it is not created in the reaction, but it is also still present. So we would want to show that at the particulate level that I would still see some aluminum left over. And if this was our lab that we did, we would see that silvery white metal on our filter paper when we filtered out our copper. So when we think visually, what would we see? At the macroscopic level, we also are thinking about, at this particulate level, what would account for the fact that we saw that. Okay? All right, and then finally, that's our model. Our model is done. Hopefully that makes sense. Our limiting reactant is the thing that runs out. So for this one, our limiting reactant was our copper 2 chloride. And as we said, our aluminum was in excess, and our theoretical yield is how much product can we make. And I can literally just count in my product box what I have. So I have 2 moles of AlCl3, and I have 3 moles of copper. So my theoretical yield comes from math and comes from that balanced equation. And luckily we're using moles instead of grams, so our numbers are, nice and round. But if they were masses, then it would be different. We wouldn't be able to model that really at the particulate level. All right, so I hope that helps. Let me know if you have any questions, and I hope you have a great day.